All right, class. So today we're going to be looking at residual values. And before we look at our examples, we're going to look at some key concepts and definitions. And we're going to start out with our first definition being residual. Residual is the air distance from the line of best fit to the point in the data set. So when we look at that, we're going to be comparing the line of best fit to all the points that's in the scatter plot. And we're going to be calculating how far those points are from that line of best fit. Now, in order to do that, we got to follow a formula where we're going to take the observed value and subtract it from the predicted value. Now, observed value can actually be also be called actual value, but it's really just the y value of the given points. So all the dots are given points. So we're going to be looking at the y values of that, and we're going to subtract it from the predicted value, which is the y value of the line of best fit. The line of best fit has points all up and down it. Now, we might not have dots there, but there are points. And those points are predicted values of what they said it should be. So, also, that the order that we set up this equation is important. We must put the actual value first and subtract it from the predicted value. That's the only way we'll be able to get the residual value. Okay? Now, that number can be a positive or a negative number. So if you get a positive or a negative number, that's okay. But making sure every time we solve it, we put it in the correct order for subtraction. Observed value first, subtract it from the predicted value. And then we're going to look at the residual plot patterns. Now, when we look at the residual plot patterns, we're trying to find out if the residual plot pattern is the appropriate model. And the way we do that is we ask ourselves a question: do the residual exhibit a clear pattern? It says in a good residual plot, the residual exhibits no clear pattern at all. So if we looking at it like in the example that is here in the picture, we can't really tell what it's doing. It's not even going up, down, it's not curving, it's not doing anything. There's no pattern that we can see. So because there's no pattern that we can see, that is a good regression model. Okay? Now on the other side of that is the bad regression plot. So the bad residual plot, the bad residual plot. The bad residual plot exhibits some type of pattern such as a curve or a wave. Okay? So looking at the pictures that we have, you'll notice that in one that we see a definite curve. We can follow it. This one to me looks like it's making like an X. We can follow that. And then in the third one, we can see that it's increasing. So if we're looking at those, we can definitely tell there's a pattern there. So if we see a pattern, that is a bad regression model. No pattern is a good regression model. So now that we have an understanding of some of the key concepts that we need for residuals, let's look at our first example. All right, so let's look at example 1. Example 1 says the equation below is used as a linear model for predicting y, the score a student gets on a test based on x, the number of hours the student studies. The equation is y equals 15 plus 11x. It says what is the residual for a student who studies for 4 hours and scores a 70 points on the test. So we're going to start out by, underlining and picking out the key things from the problem. So in this problem, we're going to know that we need to be looking at a linear model, that the y value is the score the students get on the test. The x is the number of hours the student studies. We know the equation, and that we're looking for the residual. Now, the residual is dealing with the studies for 4 hours and the score of 70 points. Now, the 4 is going to be your x value. The 70 in this one is the actual score that they made. So by it being the actual score, that's your actual value that we're going to need for the residual formula. Okay? But now we have to go find the predicted value. In order for us to find the predicted value, we're going to take the equation, we're going to plug 4 in and see what the result will be. So the equation they gave us was y equals 15 plus 11x. we're going to take and replace the x with 4. So that's going to give us 15 plus 11 times 4. We keep going, that's going to give us 15 plus 44. And if we add those together, we get 59. So this right here is the predicted score that they should have made. Okay. Now, like we said before, for us to find the residual value, we have to take the actual and subtract it from the predicted. And it must be in that order. So the actual score is what they got, which was 70. And the predicted we found was 59. So when we subtract those two, we get 11. So the residual value for example 1 is going to be 11. So the distance from the point to the line of best fit is 11. Now let's look at example 2. All right, so let's look at example 2. Example 2 says that the table below shows the value VT in dollars of a car T years after it is manufactured. Based on the best fit linear model for the data, what is the residual value for the data point 7 and 36,400? So now in order for us to find the residual value, what we're going to do is we're going to enter the table into Desmos. When we enter that table into Desmos, we're going to add a regression, and the problem already stated that we need the best fit linear model. So we're going to make sure we have a linear regression. And now once we get our data from that, what we're going to be looking for in that box is going to say residuals. And underneath residuals, you'll see E1 and the word plot. We're going to click the word plot, and that's going to list out all of our E1s. E1 and Desmos is the residual values. Okay, so now let's do that in Desmos and we get our answer. So going to Desmos with plus sign table, fill in our table. So we have 1, 3, 4, 6, and 7. And we have 45,950. We got 40,196. 38,241. 37,200, and 36,400. Now we hit our add regression. It's already on linear regression. Then we look for the word residuals in the list of data, E1, and there's the word plot. Click that. All of our E1 values will pop up. Now we're only focused on the one value that they're asking us for, which is at the order pair 7 and 36,400. Now if we look at the table for 7, right beside that, you'll see the E1 value is 983.36842. Now we're going to round that. So we're going to say roughly that our residual value for this one is 983.37. So we'll find, if it was an answer choice that we had to choose, we'll find the one that's the closest to what we have as our residual value. So now, again, just going back over the steps, to find the residual value in Desmos, you'll enter your table in Desmos, you'll add your regression, it'll tell you whether it's linear to exponential. You choose that. Then you look for the word residual. Then underneath that, you'll see E1 and the word plot. You'll click plot and it will make your E1 points. Those E1 points in Desmos is your residual values for each one of those order pairs. And then you just find the one that you need to answer your question. Okay, so now let's move on to example 3. All right, so let's look at example 3. It says that the table below shows the amount a banquet hall charges to feed different size groups of people. Using a linear model, what is the approximate residual value of the cost to feed 14 people? So in this problem, we already know that we're looking at a linear model. We already know approximate means we're going to get close to it, and we know we need the residual value. And we need that residual value for 14 people. So now we're going to go to Desmos, and in Desmos we're going to start a new table. So we're going to click the plus sign, add table. Then we're going to enter our values. So we got 10, 14, 21, 23. Then we got $200, $252, $441, $471. Then we're going to hit add regression, and then we look for the word residuals with the E1 and hit the word plot. Now the question asked us to only focus on the point with 14 people. Okay, so we go to our table, we look for the E1 value of that, and when we find our E1, which is our residual value for this one will be roughly negative 22.61. So all we did was type the values in, hit E1 plot. When you hit E1 plot, it will give you your residual values, and you go find in your table for the point that they were looking for, which is at 14 for us. Then right beside that, you will see your list of E1s and Desmos. Then you pull the number that you need, and because it said approximate, we're going to find the answer choice that is the closest to it. And for this one, our E1 was negative 22.61. All right, so now let's look at our last example. All right, so let's look at example 4, our last example. It says Laura chose to use a linear model for the data she gathered, which residual plot shows that the linear model was the best choice for Laura's data. So in this problem, we got to refer back to our definition side where it was talking about the residual plots. And in those residual plots, it says that for us to have a good residual plot, we need to know that there should be no pattern. So no pattern. In a no pattern, we have a good residual plot. If we see a pattern, so if we have a pattern, that equals a bad residual plot. So we're going to look at the 4 plots that we have, and we're going to determine if those plots that are given shows a pattern. If it shows a pattern, then that's bad residual. If it's a no pattern at all, that's good. That's the one we need. Okay, so looking at the first graph, you will see that those dots follow a straight line. Because they follow a straight line, that's a pattern. So we don't need that one. We're going to write bad. This is a bad one. Okay, the next one, you'll notice that as we follow those dots, it makes a curve. So in that curve, that means it's following a pattern. That's going to be another bad one. Then we're going to look at the third one. The third one, we follow it from the left side of the graph to the right. We'll notice that it is going up. It has a curve to it as well. So because of that, this is a bad residual plot. Okay, and then the last one. And in this last one, we can't really follow the dots like we did in the other 3. So because we can't follow the dots, there's no pattern. That means this is the good or the best choice that we have. So no pattern tells us that we have a good choice here as an answer. So out of the 4 choices that we have provided, the last one was the one that makes a good residual plot. So now that we have covered everything dealing with residuals, if you have any questions, please don't hesitate to ask.